Hi, and welcome to lesson 13.4, which is about using technology to conduct a simulation. So how can you use technology simulations to estimate probabilities? That's our essential question. And we're going to design and conduct a simulation for a simple event. You can use a graphing calculator or a computer to generate random numbers, and I have my calculator that I've used in previous lessons. I'll show you how I do that in a moment. Our example 1. A cereal company is having a contest. There are codes for winning prizes in 30% of the cereal boxes. Okay. Find an experimental probability that you have to buy exactly 3 boxes of cereal before you find a winning code. Let's choose a model. The probability of finding a winning code is 30%, which is 3 out of 10. Use whole numbers from 1 to 10. Okay, because there are 10 numbers here that we can choose from. Let 3 numbers represent buying a box with a winning code. Okay, so if when I'm choosing my random numbers, if I get a 1, 2, or 3, that's a winning code. If I get 4 through 10, that's not a winning code. We're going to generate random numbers from 1 to 10 until you get one that represents a box with a winning code, and then you stop. Record how many boxes you bought before buying the winning code, before finding the winning code. 5 numbers generated, 9, 6, 7, and 8, and then 1. 1 represents a winning code right there. So you would stop. Perform multiple trials by repeating step 2. Okay, so we keep doing that. Find the experimental probability. So to explain this here, because it took me a few moments to figure this out, remember the winning code is 1, 2, or 3. So this person in first trial generated a 9, then 6, 7, 8, and then 1. And as I showed you there, 1, that's a winning code. 5 boxes were bought. 1, 2, 3, 4, 5. This one, they nailed it on the first one. 1 box was bought. And here there are 4 numbers, 4 until you got to a winning code. And another 4, 1, and so on the 8th trial, it took 3 boxes to get to a winning code right there. And that's what we were looking for. If you come back to the question here, find the experimental probability that you have to buy exactly 3 boxes. Well, that happened, but it took the 8th trial for it to happen. And it only happened one time. It didn't even happen afterwards. So it happened one time out of our sample space of 10. So that's how we get the experimental probability is 1 out of 10, which is equal to 10%. Next. An elephant has a 50% chance of giving birth to a male or female calf. That's a baby. That's what they call a baby elephant. Use a simulation to find an experimental probability that the elephant gives birth to 3 male calves before having a female calf. And the hint is use zeros and ones. 0 represents a male and 1 represents a female. Generate random numbers until you get a 1. Okay. Well, what I generated 3, but I could have just stopped when I got to 1. And what I did is I used this right here and my random integer. So it's picking numbers between it's either picking 0 or 1. So when I hit enter right here, you can't tell. I'm going to keep hitting enter, and you'll see this 0, 1, and then it picks 0 and a 0 and a 0 and so on. And so I did that, and I generated random numbers, and I recorded all of them. So 3 males first, nope, didn't happen because I would have to get, I believe, 0, 0, 0. Yeah, because 0 represents a male. So I'd have to get 0, 0, 0. I didn't get it there, 0, 0, 0. Nope. I got it on the... strange, on the 8th try, just as they did in the example. It happened one time out of 10. So the A trial had 3 males first, and the experimental probability is 1 out of 10, or 10%. Next, designing and conducting a simulation for a compound event. You can use random numbers to simulate compound events as well as simple events. Our example 2, suppose there is a 20% chance that a particular volcano will erupt in any given decade. That's a period of 10 years. Find an experimental probability that the volcano will erupt in at least one of the next 5 decades. Well, you can choose a model first. That 20% is 20 out of 100. which is equal to 1/5. So that's where they get the 1/5 from. Use whole numbers 1 through 5. Okay. Let 1 represent a decade with an eruption. So 1 through 5, see at least 1 in the next 5 decades. So we're looking for the eruption. And so if 1 in the next 5 decades, we can use whole numbers 1 through 5 to represent those decades. And we'll say number 1, if you get a 1, that tells you that's a decade with an eruption. 2, 3, 4, 5, there was no eruption in that decade. So that's the numbers for our simulation. And then from there, we're going to generate 5 random numbers from 1 to 5 and record the decades with an eruption. 5 numbers generated. So here they are, 3, 1, 3, 4, 2. And the eruption decade was the 1. Remember, 1 represents a decade with an eruption. So there you go. So there was 1 out of the 5. So perform multiple trials repeating step 2. Calculate the percent of trials which there was an eruption in at least 1 of the 5 decades. So we're looking at there was 1, and we have here's an eruption 1, 2, 3, 4, 5 has eruption decades. So 5 out of the 10 trials there was an eruption in at least 1 of the 5 decades. See, these have 2, but they don't count twice. It's just does it have any eruption decades? The experimental probability of an eruption in at least 1 of the next 5 decades is 5 out of 10, or 50%. And finally, our your turn question. Matt guesses the answers on a quiz with 5 true-false questions. The probability of guessing a correct answer on each of the question is 50%. It's true-false. Use a simulation to find an experimental probability that he gets at least 2 questions right. And hint, use zeros and ones. Zeros represent incorrect answers and 1 represents correct answers. Perform 10 trials, generating 5 random numbers in each, and count the number of ones. Once again, I use this, and I keep entering that, and I enter the number that shows up. Ooh, lots of zeros. Okay, so I did that, and let's see. Exactly 2 questions right. Well, when did that happen? That happened right here, and right here. Happened 2 questions right exactly, and 2 out of the 10. Oh, I'm sorry, no, 2. 3 out of the 10 had 2 questions right. So 3 out of the 10, and that's equal to 30%. And so that's what you need to know about using technology to conduct a simulation. Thanks for watching.